This is not a difficult topic, guys. I'm going to walk you through it. It's going to make perfect sense. So, yeah, it looks a little messy, but trust me, you'll be fine. So linear independence means that no vector is a multiple of the other in a set. Each vector is one of a kind in the set. And we can test to see if a set is linearly independent or dependent. So these are the 5 steps I'm going to walk you through. So step 1. Look at your set of vectors and see if there are any linearly dependent vectors before you do any work. So as you can see here, 2, 0, 0 is dependent on 1, 0, 0 to make itself happen. 1, 0, 0 doesn't depend on anyone. So the real linearly independent set for V1 would be this one. So we get rid of 2, 0, 0. But for a longer sequence, for a vector set that has more vectors than this and it's not so obvious, we need to apply a certain strategy. So next we apply a formula. If a set is linearly independent, there will be no linear combination of the vectors. So we do this. We equate it to 0, because that means that beta 1, beta 3, and beta 2 have only one unique solution. So essentially, to put this in equation form, is just that what multiple of 1x plus what multiple of 4x plus what multiple of 2x will give us 0. And we apply this to y as well as to z. And of course, don't forget your equal sign because, it's a system of linear equations. So next, you want to put it into matrix form to make things easier, because this is much easier to solve than this mess. Now you want to solve it. It's the fun part. Look at that. Yeah, it gets fun. But, if you perform all the row operations correctly, you should get reduced row echelon form via Gauss elimination. Lastly, you get to conclude. So, what it means when we get reduced row echelon form is that all of our coefficients are equal to 0, which is the only solution, the only linear combination that we get when we multiply everything. Because if this was 1, I'll show you guys in a second what happens if you don't get reduced row echelon form. So 1, you want to check to make sure your row operations are all correct. Go back, check over them. And if you still don't get a row-reduced matrix, you don't have a linearly independent set. Now why is that? Well, have a look at this. What does this mean? This means that some coefficient beta 1 and some coefficient beta 2 is equal to 0. So beta 1 is essentially negative beta 2, which means that, one of your vectors is just a negative version of the other vector. And the same goes for this one, just in a more different form. So make sure that you get a reduced row echelon form, otherwise your set is not linearly independent. So you can remember this by a simple acronym, TAXEE. So inspect, to make sure that, you can obviously see that you're going to need to go through this process, apply the formula, put it into matrix form, solve using Gauss elimination, and then conclude. Alright, thanks for watching, guys.